should be on standard D3. Now, it seems like we have a lot to go through in 15 minutes, but really it's just going to be me talking through each page, and then as I'm talking, you'll be filling out some things. There's no real math here to do. It's just, again, talking about the different types of surveys that are done. Again, because you will come across this in any kind of information that you read, so being aware of what kind of information you're being given allows you to make some educated decisions about it. Alright, we've already discussed that when conducting a survey, it is best to try and select an unbiased sample to ensure that the data gathered best represents the population. Random samples are also preferred because they are less likely to be biased. In designing a survey, it's also very important to word survey questions carefully, questions that are flawed. So, if a question is flawed, it means it's poorly worded so that responses might not accurately reflect the opinions or actions of the population. In a way that leads into inaccurate results are called biased questions. Okay, so basically, unbiased, random samples are good to ask, but then the actual survey that's given can also not be biased. So there's three ways that it could be biased. First way, the wording of the question may encourage or pressure the respondent to answer in a particular way. The second way, the question may be perceived as too sensitive to answer truthfully. And three, the question may not provide the respondent with enough information to give an accurate opinion. Surveys, there's a lot of research that goes into how to word questions and how to make surveys, because if you want accurate results, you have to be very careful of bias. Being aware of bias in questions, if you have to give a survey, helps you make a good survey, but will also help you in analyzing the results of surveys, where the data is applicable to something you need. For example, survey results about the safety or comfort of a vehicle you're looking to buy, or survey results, if you have kids someday, on what type of car seat is the best and safest. So that's information that you need to know if there is bias, so that you can pick the best option. For example 1, this is one thing you're going to have to do also for this standard. Identify and correct bias in survey questions. So the first question here, a reporter asks parents, do you agree with the school board's proposal for new technology in our schools? In this case, the question assumes that the person who's answering knows the proposal. So it's biased because they don't have enough information if it's under that third option. So the fix would be, you could still ask this question, just make sure they know what the proposal is. So you could state the proposal before asking the question in order to get some valid conclusions. Remember to pause if you need to. Okay, the next question here for B. A dentist asks patients, do you brush your teeth at least twice per day and floss every day? Patients might be embarrassed. It fits under that second biased question because since the dentist is asking it and you have to answer truthfully to that dentist, somebody might lie and say they do and they actually don't because they don't want to be embarrassed in front of the dentist. So the fix would be make sure that you, maybe if you just are trying to gather data and you don't need that information for that particular patient, that you can get that data, but just have patients answer anonymously and put the answers into a box. And that way they can be honest because they know it's not attached to them. Alright, we've talked about surveys a lot, but there are some situations where different data gathering techniques are required. For example, many studies are designed to try to determine or compare two groups. So like all the surveys that we've talked about so far aren't really comparing one group against another, it's just like gathering information. The two that you could have are an experiment. An experiment imposes a treatment in order to collect data on their response to that treatment. So, like medical testing, they might give one group of people the treatment and then give one group the placebo. So, they have the one group that you can monitor, let's say it's a treatment for a skin condition. You can monitor how the skin condition is doing. And then in the other group, where you haven't given them anything, you can monitor how that skin condition is as well. So you're comparing the two conditions. Or in this case, like, it doesn't have to be a person. You can add methanol to gasoline, and then the comparison would be how it transfers to fuel efficiency. So you're administering a treatment, you're adding methanol, and then your data gathering is how fuel efficient you are after that. An observational study used when it's difficult to control or isolate the variable being studied. This observes individuals and measures variables without controlling the individuals or their environment. So maybe you just want to see how many students in a day look like they've gotten enough rest. That's just observing students' behavior and monitoring their awakeness all day. You're not controlling the individuals. You're not telling them they have to go to bed at a certain time. You're just watching. So that would be an observational study. The other part of this standard is to be able to identify experiments and observational studies. So for example 2, you have 2 situations. A researcher asks college students how many hours of sleep they get on an average night and examines whether that number of hours of sleep affects students' grades. This is definitely an observational study because the researcher gathers data without controlling the individuals or applying treatment. So all that he's doing is, this researcher gets information about how many hours of sleep they get and then compares it to their grades without giving them any kind of treatment, like making them go to bed for a certain number of hours. For B, a Parks Department employee wants to know if latex paint is more durable than non-latex paint. She has 50 park benches painted with latex paint and 50 park benches painted with non. Okay, so you're comparing 2 groups. The treatment, which is painting benches with latex paint, is applied to some individuals, the benches. This is an experiment. Okay. Flip. Controlled experiment. There's just some terms here that we just need to cover. A controlled experiment is basically 2 groups are studied under identical situations or circumstances with the exception of one variable. So let's say you have planted 10 radish seeds. You might have done this in the class once. 5 of the radish seeds go in the sun, 5 of them go in the dark. That's an experiment, but it's controlled because you have 2 groups and they're separated. Everything's the same. You water them the same. You put them in the same soil. You put them in the same container. Everything else is the same except for that one variable. One is in the light, one is in the dark. The control group in that situation with the radishes would be the group under ordinary conditions. So the ones in the sunlight, they're under ordinary conditions. The treatment group would be the ones put in the dark. You're seeing how the darkness affects the growth of a radish seed. A randomized comparative experiment means the individuals are randomly assigned to the control group or the treatment group. So in the radish seed scenario, that would be a randomized comparative experiment because you're just arbitrarily taking a radish seed. You're not like saying, oh, every radish seed that's this size is going to go in the sun and every tiny radish seed is going to go in the dark. You're just randomly picking up the next radish seed and planting it. That would be that kind of experiment. Randomization minimizes bias and produces groups of individuals that are theoretically similar in all ways before the treatment is applied. If you do not have a randomized comparative experiment, so if there's something that's already separating the 2 groups, they're not randomly assigned, that there's already a split there, you're not going to have conclusions that are valid. So just keep that in mind. So for example 3, you have this study. We're supposed to read this study and determine if it's a comparative experiment or not. If it is, we're supposed to describe the treatment group, and the control group, kind of like what we did with the radish seeds. If it is not, explain why not and discuss whether the conclusions drawn from the study are valid. Okay, so at Ashland Middle School, students were given the choice of drinking milk or other beverages. 50 students who chose milk were monitored for 1 year, as were 50 students who chose other beverages. At the end of the year, students in the milk group had 15% fewer cavities than students in the other group. All right, this is not this is not a comparative experiment. The main reason being you didn't randomly assign them to a control group and a treatment group. But it's also, plainly, it's an observational study. They're just watching them pick milk. They're not giving them a treatment. They're not saying you 50 have to drink milk and you 50 don't get to drink milk. That would be assigning a treatment. Here, the kids get to choose, and so they're just observing what happens at that point. So, because it's not, we have to discuss whether the conclusions are valid. It may or may not be valid. Other factors, however, lead into maybe why the students who chose milk have fewer cavities. For example, and you could argue for lots of different reasons, but since they chose milk rather than other beverages, they might have other healthy eating habits that also lead into having fewer cavities. So, because it's not a controlled comparative experiment, you can't say that the conclusions are valid for sure, because there are multiple reasons why those kids might have fewer cavities. Okay, so doing that is also part of the standard. Excuse me. Okay. The last couple parts here are kind of just summing up what we just got done talking about, with just some kind of concluding statements here. Part of our job as informed consumers is to be able to recognize a well-designed study and interpret the results for our own benefit and information. Randomization is a key element of well-designed studies. How randomization applies to different kinds of studies varies, as shown below. So, we talked about how to do random sampling for a survey, draw numbers out of a hat, use the random number generator, that kind of thing. Observational study, random samples selected for the groups being studied. So, if you're just observing a group of students, you're just randomly, like you're observing the whole group, but maybe randomly only picking 2 or 3 groups to focus in on. In an individual, or how to randomize experiments, is you randomly assign individuals to either the control group or the treatment group, not based on any other qualifications, just randomly assigned. Surveys do not compare groups, and so they don't address cause and effect. So if you want to see if this thing causes this other thing, if putting radish seeds in the dark causes them not to grow, then you have to do something else. You can't just do a survey. Good observational studies and experiments are designed to be comparative, meaning you do the study because you're trying to compare 2 different results. And usually it's to compare data from 2 or more groups. A lot of times it's just 2 because that's easier to keep track of. So comparative studies and causality. An observational study can identify correlation between variables but not causality. Basically that means that you can say, yeah, there's a correlation. For example, the example I gave, exercise in older people tends to lead to longer life, a longer lifespan. But we can't say that exercise will give you a longer lifespan because other factors are being ignored. Maybe they have an injury and they can't exercise, but they still live a long time. Like you can't, there's a correlation, but you can't say that exercising will cause longer life because there's other factors that are ignored. A rigorous random comparative experiment, which eliminates sources of variation other than the controlled variable, meaning you're able, and that's what the rigorous part means, is you are able in the 2 control groups, or the 2 groups, to keep everything else exactly the same, except for one thing. If you can do that, then your results are valid. A lot of times you can't, especially with people, control everything. But in other scenarios you can. Like in the radish seed scenario, I can control every other factor affecting that besides the one. Meaning I'm going to put these in the light and these in the dark. So there are ways to do a rigorous random comparative experiment, but it's hard work. You have to really make sure that everything else is exactly the same except for that one thing you're comparing. Alright, last example here. Design an experiment or observational study. So I'm going to leave this here as I'm kind of talking through it. Explain whether the following research topic is best investigated through an experiment or an observational study. Then explain how you would design the experiment or observational study. So you want to know if listening to music using earphones for more than 1 hour per day affects a person's hearing. The treatment is listening for more than an hour. It may affect hearing, so this needs to be an observational study, meaning you can't ethically take two groups of students or people and say, you are going to listen to music with earphones for 4 hours a day, and you are not going to listen to it. You can listen to it for up to an hour, but you can't listen to it past an hour. Because it could affect their hearing, and that's why you're doing the study, but because it could damage them, it's not ethical to say, I'm going to make you do this. So it has to be an observational study because of that. So maybe one way you can design the observational study, you randomly choose one group who already listens to music for more than 1 hour a day. You randomly choose one group who does not listen to with headphones for more than 1 hour a day, where the listening for more than 1 hour and under 1 hour is the only thing like putting them in that group. There's not another reason. That's what the random means. And then basically you just monitor the hearing in both groups at regular intervals. So you say every 3 months I'm going to do a hearing test on you and see where you're at. Alright, so in conclusion, there was quite a few pages here that we went through. But for this standard, you can use data from a randomized experiment to compare two treatments. You can identify bias in questions and correct the flaw. So correcting the flaw in questions is kind of like what we did in example 1. And then the rest of it, talking about the difference between experiments and observational studies, being able to identify which one it is, so saying this is an experiment, this is why, or this is an observational study, and this is why. Being able to evaluate a report and telling me if it's an experiment or an observational study. This was just talking about how random samples are good and how studies, like the experiment, if you can control everything else besides the one variable, that gives you valid conclusions to give you good data. But for the first one, you can say there's a trend, but you can't say what causes the trend. There's stuff you have to know. And then for example 4, kind of summing it all up, being able to make your own experiment or observational study. You will get good practice on this tomorrow after our formative assessment, and Wednesday and Thursday before our test on Friday. All right, that's it.